Good evening, students. Today's topic is grade 11 chemistry basic concepts. In that, we are going to discuss the subtopic empirical formula and molecular formula. See, with an example, we can discuss this topic. Before we enter into the question, let us take molecular formula of glucose, that is C6H12O6. So we know that you can take a common factor 6 here and write it as CH2O. This will indicate the total number of atoms present in the glucose molecule. But when you come to this, it just gives us the simpler ratio, or we can say that it gives information about the elements present in that. It does not give complete information. Now what is this 6 here? It is indicated as N. So later we will see the various formulae related to this. Now, what is empirical formula? The simplest ratio which will represent the number, or you can say that elements present in the molecule. So when they give a question like this, first let us formulate the table. Elements which are given here. So they mentioned carbon 40%, hydrogen is 6.67%. So the remaining is oxygen. So how to calculate the oxygen here? So 100 minus sum of C and H. So you will get 53.33. And molecular mass is given as 30. First and foremost thing, write the elements present here. We have carbon, hydrogen and oxygen. Second column is percentage. We are writing only the given information. Elements we know and percentage also we know. 40, H is 6.67% and oxygen we calculated, that is 53.33. Next, write down the atomic mass. Carbon atomic mass is 12, H is 1, oxygen is 16. So up to this we know. Next, to calculate the relative number of moles, we can just take the percentage divided by atomic mass. So what we have done, given percentage and atomic mass we know. So percentage by atomic mass will give us the relative number of moles. So that will be our fourth column. So how to calculate? 40 by 12, 6.67 by 1 and 53.33 by 60. So hope you are able to follow this. Next. After calculation, we will get 3.33. Here it is 6.67 and again it is 3.33. Next, from this you have to select the least value. You can easily identify either this or this. So 3.33 is the least value. So what we do is, all the three relative number of moles should be divided by the least number. So 3.33 by 3.33, 6.67 by 3.33 and 3.33 by 3.33. So this will give you a simple ratio. Nothing but 1, 2 and 1. So from this, what we observed, we can find out that we got the empirical formula. So what is the empirical formula we got? Nothing but carbon is 1, H is 2 and O is 1. So therefore we can write it as the empirical formula is CH2O. So up to this I think you have followed. Now the next one. If at all molecular mass is given, how to calculate the molecular formula? So first and foremost thing is, let us list out the formula what we will apply. Number 1, to get N, we will find it as the molecular mass divided by empirical formula mass. So this is the formula which should be used to find out N, where N is a common factor, what you have seen in the example of glucose. Next step. So molecular formula is calculated as N into empirical formula. So this will be your final formula, what you should do to get the molecular formula. So hope you have understood up to this. So we got empirical formula and then we have the rest of the formula here. So let us calculate. So empirical formula we have obtained as CH2O. Now, what is the empirical formula mass? So carbon is 12, then H2 2 and oxygen is 16. So we have the empirical formula mass is 30. Now let us use the formula to calculate N. So N is equal to molecular mass by empirical formula mass. We know that molecular mass is given as 30 and we calculated empirical formula mass, that is also 30. Hence N is equal to 1. Now the last step, to get molecular formula we have N into empirical formula. So what is N? N is equal to 1. What is empirical formula? CH2O. Finally what we get? We get the molecular formula is CH2O. So let us move to the next question. Now in the second question, they have given 0.29 grams of an organic compound with CH2O has given carbon dioxide and water. And vapor density is given here. So they didn't mention the molecular mass, but they have given vapor density. We can calculate molecular mass using the formula that we already know. Molecular mass is equal to 2 into vapor density. We will apply this formula to calculate the molecular mass. Now the question is, they didn't mention any percentage of carbon, hydrogen and oxygen. In such cases what to do is, we need to calculate. Earlier through Liebig's method we have obtained the formula, like how to calculate percentage of carbon and percentage of hydrogen. Nothing but atomic mass of carbon by molecular mass of CO2 into mass of CO2 by mass of organic compound into 100. So this already we are familiar. Why we got CO2? Because combustion of carbon gives CO2, and here why you got water? Combustion of hydrogen gives water. As such, 2 atomic mass divided by water molecular mass into mass of water by mass of organic compound. In both the cases, in the denominator organic compound mass is common. By substituting this, we got carbon and hydrogen. One more thing, earlier also we have calculated how to find out the percentage of oxygen. 100 minus the sum of carbon percentage and hydrogen percentage. So that also we have obtained. So first thing is, in this type of question they didn't mention the percentage. So we have calculated the percentage by using Liebig's method. Now the second part is as usual. So what we should do, we have to formulate the elements and respected percentage. So let us apply the same rule. So what is the first column? The first column will be elements: carbon, hydrogen, oxygen. Second column, percentage. So what we have calculated, that percentage we are writing. Nothing but 62.1 here. Next we got 10.34 and 27.56%. So we have calculated this. Next, As usual, third column will be your atomic mass. Carbon 12, hydrogen 1, oxygen 16. Next, to get the relative number of moles, percentage by atomic mass. Very simple. First we will write percentage, we calculated. Then we write atomic mass, percentage by atomic mass. 62 by 12, 10.34 by 1 is same. Next, 27.56 divided by 60. So here we are going to get a simple ratio. So 62 by 12. So roughly we can take 5.2 you will get. This is 10.34. Now here we will get approximately 1.72. So hope you have understood the procedure. We have followed the same thing. Now in this, what is the least number? Least number is 1.72. So we have to divide the remaining 3 using the least number. So 5.2 by 1.72, 10.34 by 1.72, and here as such 1.72 by 1.72. So now we can say that what are the values we are going to get. So this will be roughly 6, and this is around 3, and this is 1. So we got 3, 6 and 1. Therefore the empirical formula what we get is C3H6O. We have done the first step. Now what is the second step? They gave you vapor density. So let us calculate. Molecular mass is equal to 2 into vapor density, nothing but 2 into 29. So here we are going to get 58. Next, what is N? N is equal to molecular mass divided by empirical formula mass. So we have 58 as molecular mass. Now what will be the empirical formula mass? For this we have to calculate. 12 into 3, 36. This is 6 and this is 6. So 18, 3, 4, 58. Now the empirical formula mass is also 58. Therefore we can say that N is equal to 1. So hope you have understood this. Only calculated the molecular mass. Now the last one, the molecular formula is equal to N into empirical formula. So that is N is 1. Now empirical formula we got it as C3H6O. So therefore finally the molecular mass, that is molecular formula, is C3H6O. So this is the second type. So using these two questions you can solve the calculation of empirical formula as well as molecular formula. Hope you have understood this. Thank you.